It's not only a beautiful thing to watch dynamically, but it's also a fascinating problem. When you wake up in the middle of the night and you feel your heartbeat, I have a very different response to that. You think you're lying calmly asleep, but it's craziness inside. The heart itself, although we are desperately dependent upon it, is one of the most fragile organs in the sense that it does not regenerate spontaneously. Imagine if we could turn some kind of a switch so that our heart could regenerate as well as that of a salamander or a fish or a frog. There is a sense that we are facing an impediment as humans that is not insurmountable, and that's the hypothesis with which my lab works on a daily basis, to try to find out what it would take to change our fate. When damage occurs to a tissue, immune cells immediately rush in to get rid of dead cells and to launch an inflammatory response, which is absolutely critical for the healing process. But left unchecked, that inflammatory response turns into scar formation. And scar is an anathema to functional tissue restoration. In order to get at the initial cause of the scarring, we have to understand what the underlying features of a heart attack look like. And that's where the mouse comes in, because mice experience heart attacks just as acutely as humans do. Everybody's immune system is slightly different. And indeed, some people are known as good healers and do not experience the usual sequelae of a heart attack. So what we're trying to figure out is whether there are ways in which different kinds of immune systems might be better or worse for the response to a heart attack. And indeed, mice are just as variable as humans. And one of the advantages of being here at the Jackson Laboratory is that we have access to scores of mice that are related to each other like a small village, but are nevertheless individuals and unique in their genetic makeup. And so we can then look at other components of their genetic makeup against this uniform backdrop and understand in much more clear terms how genetic makeup can actually affect the way in which people respond to lifestyle and become diseased and have problems with their heart. The more we approximate the human condition, the more expensive the research gets. It's that capacity to take what we can use here at the Jackson Laboratory to the next level that will spell a new era for cardiovascular disease. But it takes people, and it takes mice, and it takes money, but most of all, it takes time.